On the morning of May 20th, 1945, Lieutenant Commander Minoru Genda stood on the tarmac at Yokosuka Naval Air Technical Arsenal, staring at an aircraft that should not exist. The airplane before him was an American F4U Corsair, bent-wing fighter, painted in faded United States Navy blue, with white stars barely visible beneath patches of fabric hastily applied by Japanese mechanics. It had crashed 2 months earlier in a rice paddy near Kasumigaura, the pilot killed on impact, but the aircraft remarkably intact. Genda was 37 years old. He'd been a naval aviator since 1928, one of Japan's finest pilots, the man who'd helped plan the attack on Pearl Harbor. He'd flown combat missions in China, led fighter squadrons over the Pacific, and survived when so many others had not. Now, in the spring of 1945, he commanded what remained of Japan's Air Technical Intelligence Unit. His job was to analyze enemy aircraft, extract their secrets, and find weaknesses Japanese pilots could exploit. But there was a problem. By May of 1945, there were no weaknesses left to find. The Corsair sitting before him represented everything that had gone catastrophically wrong with Japan's war effort. When the war began in December 1941, Japanese pilots flew the best carrier fighters in the world. The Mitsubishi A6M0 dominated the Pacific skies. It could outmaneuver, outclimb, and outrange anything the Americans had. But that was 3.5 years ago. Now, American fighters like the Corsair were killing Japanese pilots at rates that defied comprehension. The kill ratio had reversed completely. In 1942, Japanese pilots shot down 12 American aircraft for every Japanese loss. By early 1945, American pilots were shooting down 20 Japanese aircraft for every one they lost. Genda walked slowly around the Corsair. The aircraft was enormous compared to a Zero. It weighed nearly double. The engine alone, a Pratt & Whitney R2800 double Wasp 18-cylinder radial, produced over 2,000 horsepower. Japanese engines struggled to reach 1,500. The propeller was massive, 13 feet 4 inches in diameter, the largest ever fitted to a single-engine fighter. The distinctive inverted gull wings allowed clearance for that huge propeller while keeping the landing gear reasonably short. He'd read the intelligence reports. He knew the specifications. Maximum speed 417 miles per hour at 19,000 feet. Service ceiling 37,000 feet. Rate of climb 2,890 feet per minute. Range over 1,000 miles. Armament 650 caliber machine guns with 2,400 rounds total. Bomb load capability 4,000 pounds. The numbers were staggering. A single Corsair could carry more bombs than Japan's twin-engine G4M Betty bomber. But Genda hadn't come to Yokosuka to read reports. He'd come to fly it. Japanese intelligence had recovered 2 Corsairs from crash sites during the past year. Both had been damaged, but mechanics had cannibalized parts and managed to restore one aircraft to flying condition. The airplane before him was that Corsair, serial number 82,251, bureau number from the USS Essex. It had emergency landed in a field near Tsuchiura City, Ibaraki Prefecture, on February 25, 1945. The pilot, Lieutenant Commander whose name Japanese records never recorded, had been wounded but survived long enough to destroy the aircraft's radio and gun sight before Japanese soldiers captured him. The mechanics had done remarkable work. They'd patched bullet holes with aluminum salvaged from other aircraft. They'd replaced the shattered canopy with plexiglass from a captured B-24. They'd covered damaged wing sections with fabric because they had no aluminum of the proper gauge. The landing gear, which had collapsed on impact, had been rebuilt using parts from the second crashed Corsair. The propeller blades, bent in the crash, had been painstakingly straightened. The work had taken nearly 2 months. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Genda had been given 20 minutes. That's all the fuel they could spare. Gasoline was desperately scarce in Japan by May of 1945. American submarines had strangled the shipping lanes. Oil refineries had been bombed. Every litre of aviation fuel was precious, allocated only for the most critical missions. But Admiral Soemu Toyoda, Commander-in-Chief of the Combined Fleet, had personally authorized this flight. The Navy needed to understand why the Corsair was so deadly. Japanese pilots were dying every day. If flying one Corsair for 20 minutes could reveal something, anything, that might save Japanese lives, the fuel was justified. Genda climbed into the cockpit. It was cramped, despite the aircraft's size. American pilots were generally larger than Japanese pilots, but even by American standards, the Corsair's cockpit was tight. The seat was directly under the canopy hinge, which meant visibility to the rear was poor unless the pilot craned his neck, but the forward visibility was excellent. The long nose sloped down, the inverted gull wings dropped away on both sides. A pilot could see everything ahead and below. The instrument panel was overwhelming. Japanese fighters like the Zero had simple, minimalist cockpits. A few essential gauges, basic controls, nothing extra. The Corsair's panel was crammed with instruments, engine gauges, manifold pressure, oil temperature, cylinder head temperature, carburetor air temperature, fuel pressure, flight instruments, airspeed indicator, calibrated in miles per hour, altimeter, artificial, horizon, rate of climb indicator, turn and bank indicator, directional gyro, magnetic compass, fuel gauges for each of the 3 tanks, hydraulic pressure gauge, oxygen system gauge, everything labelled in English. Genda had studied English before the war. He could read the labels, but translating while flying would be a challenge. Japanese technical staff had prepared a handwritten chart in Japanese, taped to the instrument panel, identifying the most critical instruments. He found the throttle on his left, a large knob protruding from the left console. The mixture control was behind it. The propeller pitch control was a smaller lever. The landing gear handle was on the right side, next to the seat. The flap control was a lever between his legs. The startup procedure had been practiced by mechanics for days. The R2800 was notoriously difficult to start, especially when cold. But today the engine was warm. Mechanics had run it earlier that morning, checking every system. Genda turned on the master electrical switch. He set the mixture to rich. He advanced the throttle half an inch. He pressed the starter button. The engine turned over slowly. Once, twice, 3 times, then caught. The 18 cylinders fired in sequence. The propeller began to spin, and the entire aircraft vibrated with raw power. The sound was different from any Japanese engine. Deeper, louder, more aggressive. The exhaust note echoed across the tarmac. Ground crew stepped back from the propeller wash. Genda checked the gauges. Oil pressure rising. 70 pounds. Fuel pressure steady. Manifold pressure at idle. Everything normal. He advanced the throttle slightly. The engine responded immediately. No hesitation, no coughing. Just smooth, linear power. He tested the flight controls. Stick forward, the elevators moved. Stick back, they returned. Stick left, the ailerons deflected. Rudder pedals, the rudder moved freely. All controls functioned normally. He released the brakes and taxied toward the runway. The Corsair rolled heavily. Over 14,000 pounds fully loaded, though this one was light with minimal fuel. The tailwheel steering was responsive. Too responsive, actually. The Zero had light, sensitive controls. The Corsair felt heavier, more solid, but the tailwheel snapped into turns with surprising quickness. Genda lined up on the runway. Yokosuka's main runway was 5,000 feet long, more than enough for a Corsair. He checked the engine one final time. Manifold pressure, oil pressure, temperatures all normal. He advanced the throttle to full power. The Corsair surged forward. The acceleration was immediate and violent. Genda felt himself pressed back into the seat. The R2800 was producing over 2,000 horsepower, driving that enormous propeller. The aircraft gained speed rapidly. 40 miles per hour, 50, 60, 70. At 80 miles per hour, Genda pulled back on the stick. The Corsair leaped into the air. The takeoff roll had been less than 1,000 feet. A Zero needed nearly 1,500 feet. The Corsair had used 2/3 the distance while weighing twice as much. That difference came from raw power. More than 2,000 horsepower versus the Zero's 1,050. The power-to-weight ratio was nearly equal, but the Corsair's more efficient propeller and stronger structure allowed it to use that power more effectively during takeoff. Genda retracted the landing gear. The gear came up with a solid thunk. He could feel it lock into place. The hydraulic system worked smoothly. He reduced power slightly and began to climb. The rate of climb was astonishing. The Corsair was climbing at nearly 3,000 feet per minute. A Zero climbed well, about 2,500 feet per minute when light. But the Corsair, heavier and with minimal fuel, was still climbing faster. At 5,000 feet, Genda leveled off and began his evaluation. First test, straight and level flight. He trimmed the aircraft and released the controls. The Corsair flew straight, stable, solid. There was none of the lightness, the dancing quality of a Zero. The Corsair felt like it was bolted to the sky. He pushed the airspeed up, 180 miles per hour, 200, 220. At 250 miles per hour, he tried a turn. He rolled the stick left. The Corsair responded, but differently than he expected. The initial roll rate was good. The ailerons had authority. But as the airspeed increased, he felt the controls stiffen. At 300 miles per hour, he tried another turn. He had to push the stick harder. The ailerons required significant force. This was different from Japanese fighters. The Zero had light, fabric-covered control surfaces. At high speeds, those surfaces became too sensitive, too responsive. Pilots had to be gentle. The Corsair had metal ailerons, fully sealed. At high speeds, the aerodynamic forces were enormous. But the control surfaces didn't flutter or distort. They just required more force to move. Second test. High-speed dive. Genda pushed the nose over. The Corsair accelerated rapidly, 300 miles per hour, 350, 400. The airframe remained rock solid. No vibration, no flutter, just smooth, stable flight. A Zero would be approaching its structural limits at 400 miles per hour. The fabric-covered surfaces would be ballooning. The controls would be freezing up. The aircraft would want to pull itself apart. The Corsair felt like it was just getting started. At 420 miles per hour, Genda leveled off. This was faster than most Japanese aircraft could fly in level flight. The Corsair was doing it in a dive with power reduced. He tested the roll rate at this speed. He pushed the stick hard to the right. The Corsair rolled, but slowly. The roll rate at high speed was perhaps 30 degrees per second. Respectable, but not exceptional. A Zero, at this speed, couldn't roll at all. But newer American fighters, the P-51 Mustang and the P-47 Thunderbolt, could roll much faster at high speeds. Their pilots used that ability to escape when Japanese fighters got close. Third test. Turning performance. Genda slowed to 200 miles per hour and began a hard turn. He pulled back on the stick, loading the aircraft to 4 Gs. The Corsair turned well. The turn radius was tighter than he expected for such a heavy aircraft, but it wasn't as tight as a Zero. A Zero could turn inside the Corsair's circle every time at this speed. That had always been Japan's advantage. Maneuverability. The ability to outturn opponents. But American pilots had learned not to turn with Zeros. They'd learned to use speed and altitude, to attack from above, dive through, and climb away before Japanese pilots could respond. Fourth test. Climb performance. Genda pushed the throttle forward and pointed the nose up at a 30-degree angle. The Corsair climbed like it had rails to the sky. 3,000 feet per minute. No, faster. 3,200. The manifold pressure held steady at 54 inches. The propeller was biting efficiently into the thin air. At 15,000 feet, he leveled off and checked his fuel. He'd used nearly half his allocation. 10 more minutes remaining. Fifth test. Visibility. He looked around carefully. Forward visibility was excellent. Down visibility was good. The inverted gull wings gave a clear view below and to the sides. but rear visibility was poor. The canopy framing blocked much of the view behind. The armor plate behind the seat blocked even more. A Japanese fighter approaching from 6 o'clock high would be invisible until very close. But American pilots didn't worry about that angle. They had radar-equipped fighters, ground controllers, and numerical superiority. They rarely flew alone, where a single Japanese fighter could bounce them, unaware. Genda checked his watch. 18 minutes had elapsed since takeoff. He had perhaps 3 minutes of fuel remaining. He turned back toward Yokosuka and began his descent. The Corsair descended as smoothly as it had climbed. The controls remained responsive. The engine purred along at reduced power. He lowered the landing gear. It came down solidly. He extended the flaps. The aircraft slowed predictably. He lined up on final approach. The Corsair floated toward the runway. At 100 miles per hour, he crossed the threshold. At 90, he pulled the throttle back. The Corsair settled onto the runway with surprising gentleness for such a heavy aircraft. The landing gear absorbed the impact smoothly. He applied brakes. The aircraft rolled to a stop in less than 2,000 feet. He taxied back to the ramp and shut down the engine. 20 minutes. That's all it had taken. 20 minutes to understand why Japan was losing the air war. Genda sat in the cockpit for the moment after the engine stopped. Around him, mechanics and engineers waited for his report. Admiral Toyoda would want a detailed assessment. Pilots would want to know if there were weaknesses to exploit, but Genda already knew what his report would say. The Corsair had no critical weaknesses. It was simply better in almost every measurable way. It was faster than Japanese fighters. It climbed better. It could dive faster. It was more heavily armed. It could carry bombs. It had longer range. It was built like a tank, with armor protecting the pilot and self-sealing fuel tanks that wouldn't explode when hit. And most critically, it was produced in overwhelming numbers. By May 1945, American factories had built over 10,000 Corsairs. Japan's entire aircraft production for 1944 had been 28,000 planes of all types. A single American aircraft model exceeded 1/3 of Japan's total output. The question wasn't how to defeat the Corsair. The question was how Japan had ever believed it could win a war against a nation capable of producing weapons like this. Genda climbed out of the cockpit and walked directly to the operations building where Admiral Toyoda's staff officers waited. His uniform was soaked with sweat, despite the cool May morning. Flying the Corsair had been physically exhausting. The controls required constant force. The aircraft demanded attention. But that wasn't why he was sweating. He was sweating because he'd just flown the future, and Japan wasn't in it. The briefing room was sparse. A single table, wooden chairs, a chalkboard. 3 staff officers sat waiting. Captain Toshio Abe, Chief of Air Technical Intelligence. Commander Saburo Sakai, one of Japan's most decorated fighter pilots with 64 confirmed kills. And Lieutenant Koji Tanaka, an engineer from the Yokosuka Technical Arsenal. They'd all been watching from the control tower. They'd seen Genda's takeoff, watched him climb out of sight, tracked his return. Genda sat down heavily. A clerk brought tea. He sipped it slowly, organizing his thoughts. The officers waited. Finally, Abe spoke. "Your assessment, Commander?" Genda set down the teacup. "The Corsair is superior to every fighter we have in operational service. It's faster than the Zero, the Shiden, the Raiden. It climbs better, it dives better, it's more heavily armed, and it's built to survive damage that would destroy our aircraft." Sakai leaned forward. Sakai had been shot down 3 times, wounded twice, lost an eye to a B-17 tail gunner over Guadalcanal in August 1942. He'd survived by skill and luck. "Weaknesses?" he asked. "There must be something we can exploit." Genda shook his head slowly. "At low speeds, below 200 miles per hour, a Zero can turn inside it. But American pilots don't fight at low speeds anymore. They've learned. They attack from altitude with speed. They make one pass and extend away before we can turn to engage. The Corsair's speed allows them to choose when to fight and when to disengage." "Visibility?" Tanaka asked. The reports from China mentioned poor rear visibility in American fighters. The rear visibility is limited, Genda admitted. But it doesn't matter. American pilots rarely fly alone. They operate in divisions of 4 aircraft, with radar support from ground controllers or shipboard directors. If a Japanese fighter gets behind one Corsair, his wingman sees it and calls a warning. They work as a team. Our pilots are trained to fight individually, to rely on personal skill. The Americans have systematized air combat. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Abe pulled out a folder. Inside were intelligence reports dating back to 1942. When the war began, he said, we had detailed intelligence on American aircraft production. In 1941, the United States built approximately 19,000 military aircraft total. Our analysts estimated they could reach perhaps 30,000 per year by 1943 if they mobilized completely. Those estimates were approved by the Naval General Staff. They informed our strategic planning. He opened the folder and spread photographs across the table. Aerial reconnaissance photos, taken over American aircraft factories. Willow Run in Michigan, Boeing in Seattle, Douglas in Long Beach, North American in California. The factories were enormous. Some covered millions of square feet under single roofs. In 1944, Abe continued, American aircraft production reached 96,000 military aircraft. 96,000. Our intelligence estimates were wrong by a factor of 3. We didn't understand what American mass production could accomplish. Sakai picked up one of the photographs. It showed rows of B-24 bombers lined up outside, Willow Run, waiting for test flights. He counted 30 aircraft visible in the photo. How many of these? He asked. The Americans built over 18,000 B-24s, Abe said, plus 12,000 B-17s, plus over 12,000 Corsairs, plus 15,000 P-51 Mustangs, plus 15,000 P-47 Thunderbolts, plus 12,000 F-6F Hellcats. The list continues. Genda did the mathematics in his head. Just those 6 types totaled over 84,000 aircraft, more than Japan's entire production over 4 years of war. And we're still producing what? He asked. 25,000 aircraft per year, at maximum capacity? Less, Tanaka said quietly. Much less. Bomb damage to factories has reduced production significantly. Raw material shortages have worsened. Aluminum is critically scarce. We're using wood and fabric for aircraft that should be all metal. Quality control has deteriorated. Engine reliability is poor. Many aircraft are shot down not by enemy action but by mechanical failure. The room fell silent. Outside, mechanics were refueling the Corsair for storage. They worked slowly, carefully, knowing this might be the last time anyone flew it. Fuel was too precious. Every litre had to be saved for operational missions, for the kamikazes being prepared for the final defence of the homeland. Abe pulled out another document. This is a translation of a Vought Aircraft Corporation specification sheet for the F4U Corsair. We recovered it from a shot-down aircraft last year. The specifications are remarkable. He read aloud. Power plant. Pratt & Whitney, RA 2800-8W Wasp, 18-cylinder 2-row radial engine. Maximum power, 2,250 horsepower, with water injection. Normal power, 2,000 horsepower at 2,700 RPM. The engine alone weighs 2,360 pounds. Sakai whistled softly. Japan's most powerful operational engine, the Nakajima Homare, produced 1,800 horsepower and weighed over 1,900 pounds. The American engine produced 25% more power while weighing only 20% more, and it was reliable. Japanese engines frequently failed after 50 hours of operation. American engines routinely lasted hundreds of hours. Armament, Abe continued. 6 Browning M, 2 50 caliber machine guns, 4 in the wings, 2 in the fuselage. Total ammunition, 2,400 rounds. Rate of fire, 800 rounds per minute per gun. That's 4,800 rounds per minute combined. The numbers were staggering. A Zero carried two 20mm cannons with 60 rounds each and two 7.7mm machine guns with 600 rounds each. Total firing time, about 30 seconds before ammunition exhausted. The Corsair could fire continuously for 30 seconds and still have ammunition remaining. And the 50 caliber rounds were devastating. They could penetrate armor, destroy engines, shred control surfaces. Bomb load, Abe said. Maximum 4,000 pounds. Typical load. 2 1,000-pound bombs or 8 5-inch rockets. The Corsair can carry more bombs than our G4M Betty bomber while flying faster, higher, and farther. Tanaka shook his head. The engineering is impressive. The engine produces sufficient power to overcome the weight penalty of armor and self-sealing tanks. Our aircraft must sacrifice protection to achieve performance. The Americans don't have to choose. They have both. There's more, Abe said. He pulled out another photo. This one showed the interior of an American aircraft factory. Workers, mostly women, assembled fuselage sections on a moving assembly line. The Americans build aircraft the way they build automobiles. Standardized parts, sequential assembly. One aircraft every hour from a single factory. We can't match that. Our aircraft are still, built like craftwork, each plane slightly different, custom fitted. It's beautiful craftsmanship, but it's slow. Genda stood and walked to the window. Outside, the Corsair sat on the ramp, surrounded by Japanese aircraft. A few remaining Zeros, some Shidens, Japan's best current fighter, a couple of Raidens, all inferior, all produced in numbers too small to matter. When did we lose? He asked quietly. When did this war become unwinnable? Nobody answered immediately. The question was dangerous. Defeatism was punishable. Officers had been court-martialed for less. But here, in this room, among men who understood the technical reality, the truth could be spoken. December 7th, 1941, Sakai finally said. The day we attacked Pearl Harbor, we started a war with a nation that could outproduce us 10-1. We bet everything on a quick victory, on breaking American will before American industry mobilized. We lost that bet. Abe nodded slowly. Our intelligence failed, fundamentally. We assessed American military strength in 1941 and saw a small peacetime force. We saw obsolete aircraft, undertrained pilots, weak defenses. What we didn't see was potential. We didn't understand that American industry could be redirected, that automobile factories could build aircraft, that a nation producing 4 million cars per year could produce 100,000 aircraft per year. The Germans made the same mistake, Tanaka added. Their intelligence officers looked at American aircraft production in 1939 fewer than 3,000 planes and concluded the Americans couldn't build aircraft at scale. When Roosevelt announced plans to produce 50,000 aircraft per year, the Germans called it propaganda. Impossible. The Americans built 96,000 in 1944 alone. Genda turned back from the window. What do we tell the pilots? They're going up against Corsairs and Hellcats and Mustangs every day. They're dying. They want to know how to fight these aircraft. What do I tell them? Sakai met his eyes. Sakai had been there from the beginning. He'd flown Zeros over China in 1938, over the Philippines in 1941, over Guadalcanal in 1942. He'd watched Japan's advantage erode month by month, year by year. You tell them the truth, he said. The Corsair is faster, so don't chase it. It climbs better, so don't try to outclimb it. It has more firepower, so don't trade shots. It's heavier, so you can outturn it at low speeds. That's your only advantage. Get slow, get close, and hope the American pilot makes a mistake. And if he doesn't? Genda asked. Sakai's expression was grim. Then you die. The meeting ended shortly after. There was nothing more to say. The technical assessment was complete. The Corsair was superior. Japanese pilots would continue flying inferior aircraft against overwhelming numbers of superior opponents. The outcome was inevitable. But Genda had one more duty. He had to write the formal report for Admiral Toyoda, the report that would document everything he'd learned in 20 minutes of flight time. He returned to his office and began writing. Report on flight evaluation of captured F4U Corsair aircraft, May 20th, 1945. Pilot, Lieutenant Commander Minoru Genda. Duration, 20 minutes. Summary. The F4U Corsair represents a significant advance in American fighter design. It combines high speed, excellent climb rate, heavy armament, and robust construction in a single airframe. Japanese fighters currently in service cannot match its performance envelope. He wrote for 3 hours, documenting every detail: the engine power, the climb rate, the control feel, the visibility, the armament, the construction quality. He included technical specifications, performance comparisons, tactical recommendations. He described the industrial capability required to produce such aircraft, in quantity. The final paragraph was the hardest to write. Conclusion. The F4U Corsair exemplifies American industrial and engineering superiority. It is not a breakthrough technology, but rather the systematic application of adequate resources to produce an optimized design. The United States has sufficient industrial capacity to produce such aircraft in numbers that overwhelm Japanese defenses. No tactical solution exists to counter this material advantage. Victory in the air war requires either matching American production, which is impossible, or achieving a political settlement before American material superiority becomes absolute. As of May 1945, the latter option no longer exists. Genda signed the report and sealed it in an envelope marked "Most Secret." He knew it would be read by Admiral Toyoda, possibly by the Naval General Staff, perhaps even by the Emperor's military advisors. He knew it would change nothing. Japan would continue fighting because surrender was unthinkable. Pilots would continue dying because there was no alternative, but at least the truth would be documented. Years from now, historians studying this war would read his report. They would understand that Japanese commanders knew. They understood what they were facing. They recognized the impossibility of their situation. They weren't delusional or blind. They simply had no way out. 3 days later, on May 23, 1945, Genda received orders transferring him to the Philippines to organize air defense preparations. He never saw the Corsair again. American bombing raids intensified through June and July. On August 6th, a B-29 bomber dropped an atomic bomb on Hiroshima. On August 9th, another bomb destroyed Nagasaki. On August 15th, Emperor Hirohito announced Japan's surrender. The war was over. Japan had lost. The reasons were complex, strategic miscalculations, resource shortages, failed campaigns, broken codes. But, fundamentally, Japan lost because American industry could build weapons faster than Japanese forces could destroy them. The Corsair was simply one example. A very good example, but just one among thousands of weapons American factories produced. When American occupation forces entered Yokosuka Naval Base in September 1945, they found the captured Corsair still sitting on the ramp where Genda had parked it after his 20-minute flight. The aircraft was in good condition, carefully maintained by Japanese mechanics even as their country collapsed. American intelligence officers examined it thoroughly. They photographed the fabric patches covering damaged wing sections, noted the improvised canopy, documented the salvaged parts. The Corsair was shipped back to the United States aboard a transport vessel in October 1945. It arrived at Naval Air Station North Island in San Diego in November. American engineers examined it carefully, curious about what the Japanese had discovered. They found detailed notes left by Japanese mechanics, calculations of performance parameters, measurements of every dimension. The Japanese had been thorough. They'd understood the aircraft completely. What the Japanese hadn't understood was the context. One Corsair was impressive. 10,000 Corsairs was overwhelming. American industry didn't build impressive individual weapons, it built impressive quantities of good enough weapons. The strategy worked. Part 3. The Cost of Truth. The final production Corsair rolled off the assembly line at Chancevort's Dallas plant on December 24, 1952. 7 years after the war ended, the aircraft was still being manufactured. The total production count reached 12,571 aircraft. 12,571 Corsairs, more than half of Japan's entire aircraft production during 4 years of total war. But the story of the Corsair's impact on Japan didn't end with production numbers. It ended with what those numbers represented. A fundamental miscalculation about industrial capacity that cost hundreds of thousands of lives. Minoru Genda survived the war. He was in the Philippines when Japan surrendered, organizing defenses that never materialized. American forces arrived expecting fierce resistance. Instead, they found Japanese officers waiting to surrender, following the emperor's orders despite their personal shame. Genda was repatriated to Japan in October 1945. During the occupation, American intelligence officers interviewed him extensively. They wanted to understand Japanese strategic thinking, the intelligence failures, the tactical decisions. Genda answered their questions honestly. He had nothing left to hide. The war was lost. The truth no longer mattered strategically. In one interview, preserved in American archives, an intelligence officer asked Genda when he realized Japan would lose the war. Genda's answer was precise. May 20th, 1945, the day I flew the captured Corsair. Before that day, I believed we might negotiate a favorable peace. We couldn't win, but perhaps we could avoid complete defeat. After flying the Corsair, I understood we had already lost completely. We were just delaying the inevitable. The interviewer pressed him. What specifically about the Corsair convinced him? Genda explained that it wasn't one feature, it was the totality. The Corsair represented a different approach to war. Japanese fighters were designed by craftsmen who optimized every detail for performance. The Zero was a masterpiece of aeronautical engineering, achieving extraordinary range and maneuverability through brilliant design and ruthless weight reduction. But it was difficult to manufacture, required skilled workers, and couldn't be mass-produced quickly. The Corsair was designed by engineers who optimized for production. It used standardized parts, simple construction, techniques, and materials that were readily available. It sacrificed some theoretical performance for reliability and manufacturability. The result was an aircraft that was good enough in all aspects and could be built in overwhelming numbers. The Corsair wasn't the best fighter in the world, Genda told the interviewer. It was the best fighter that could be built 10,000 times. That's what we failed to understand. In industrial warfare, the best weapon is the one you can produce in sufficient quantity to overwhelm the enemy. Quality matters, but quantity matters more. After the occupation ended, Genda remained in aviation. He joined Japan's newly formed Air Self-Defense Force in 1954, serving as Chief of Staff from 1959 to 1962. He rebuilt Japanese air power using American principles, standardized aircraft, systematic training, coordinated operations. He never forgot the lessons learned during those 20 minutes in the Corsair's cockpit. Genda died in 1989 at age 84. His obituaries mentioned his role in planning Pearl Harbor, his wartime service, his post-war career. Few mentioned his flight in the captured Corsair. It was a footnote in his biography. But for those who understood the war's technical dimension, it was perhaps the most significant 20 minutes of his career. Saburo Sakai, the fighter ace who attended Genda's briefing, also survived. He'd been Japan's third highest scoring ace with 64 confirmed kills. After the war, he worked various jobs, struggling financially like most veterans. In 1957, he published his autobiography, Samurai. The book became an international bestseller. In it, he described the technical evolution of the air war. Sakai wrote extensively about American aircraft. He respected them as a fighter pilot respects worthy opponents. The Corsair, he wrote, was the most dangerous American fighter he encountered. not because it was particularly innovative, but because American pilots learned how to use its advantages. They fought systematically, using tactics that exploited Japanese weaknesses while avoiding strengths. "We trained our pilots to be warriors," Sakai wrote. "The Americans trained their pilots to be technicians. They learned their aircraft's capabilities precisely. They memorized performance charts. They knew exactly what speed they could dive, what altitude they could climb, what turn radius they could achieve. They fought mathematically. We fought artistically. Mathematics beat art." Sakai's book influenced a generation of aviation historians. It presented the Pacific Air War from Japanese perspective, explaining not just what happened, but why. American readers learned that Japanese pilots weren't fanatical or suicidal. They were professionals operating with inferior equipment and inadequate support. They fought bravely against impossible odds because duty demanded it. Sakai died in 2000, at age 84. He'd lived long enough to see Japan become an industrial powerhouse, manufacturing automobiles and electronics using the same mass production principles that had destroyed them in war. The irony wasn't lost on him. In his final interviews, he noted that post-war Japan had learned American industrial methods and applied them successfully. "We should have learned them 30 years earlier," he said. "Perhaps things would have been different." The captured Corsair that Genda flew remained in American storage until 1953. Naval Air Station North Island kept it as a training aid, occasionally showing it to classes studying Japanese technical intelligence operations. In 1953, the Navy decided to dispose of most war surplus aircraft. The Corsair was scrapped. Its engine was salvaged for parts. The airframe was cut up for metal recycling. Nothing remains of it today except photographs and Genda's detailed flight report. But other Corsairs survived. Over 60 are preserved in museums worldwide. Many more fly in private collections, maintained by enthusiasts who appreciate the aircraft's historical significance. At air shows, the distinctive sound of an R2800 engine and the sight of those inverted gull wings still draw crowds. The Corsair has transcended its military origins to become an icon of aviation history. The kill ratio statistics tell the Corsair's combat story. American naval aviators flying Corsairs achieved an 11-to-1 kill ratio against Japanese aircraft. For every Corsair lost in air combat, American pilots shot down 11 Japanese planes. The total, 2,140 Japanese aircraft destroyed by Corsairs in exchange for 189 Corsairs lost in combat. Those numbers represented skilled pilots, certainly. The Americans had good training programs, experienced instructors, and careful selection. But the aircraft mattered too. A pilot in a Corsair had advantages his opponent lacked: speed to engage or disengage at will, firepower to destroy with brief bursts, protection to survive hits, range to reach distant targets. The aircraft didn't guarantee victory, but it made victory probable. Japanese pilots in Zeros or other fighters faced the opposite situation. They had maneuverability, but only at low speeds. They had some firepower, but limited ammunition. They had range, but minimal protection. And they were outnumbered. By 1945, American carrier task forces routinely operated with hundreds of fighters. Japanese air groups had shrunk to dozens. The industrial dimension made the difference. In 1944, American factories produced over 96,000 military aircraft. Japan produced 28,000. The ratio was nearly 3.5 to 1. But raw numbers understated American advantage because American aircraft were generally better. A Corsair wasn't just one aircraft. It represented thousands of hours of engineering, millions of dollars of tooling, reliable supply chains providing aluminum and electronics, and training programs producing competent pilots. Japan couldn't match any of those elements. By 1944, Japanese industry was collapsing. American submarines had cut shipping routes, starving factories of raw materials. American bombers struck industrial targets, destroying production capacity. Japanese engineers struggled with material substitutions, using wood where aluminum was specified, fabric where metal belonged. Quality control deteriorated. New pilots received minimal training because fuel was scarce, and experienced instructors were dead. The captured Corsair represented everything Japan lacked. Genda's 20-minute flight demonstrated Japanese technical competence. They could fly American aircraft. They could understand American engineering. They could analyze American tactics. What they couldn't do was match American production. And in industrial warfare, that was the only thing that mattered. The broader strategic implications took years to understand fully. After the war, historians analyzed Japanese decision-making, searching for the critical mistakes. When did Japan's defeat become inevitable? What decisions, if changed, might have altered the outcome? Many historians identified December 7, 1941, as the decisive moment. Japan's attack on Pearl Harbor brought America into the war before American industry had mobilized. If Japan had avoided attacking America, perhaps focusing solely on British and Dutch territories in Southeast Asia, perhaps America might have remained neutral longer. Perhaps Japanese forces could have consolidated gains before facing American industrial might. But other historians noted earlier mistakes. Japan's invasion of China in 1937 began a grinding war that consumed resources and provided no decisive victory. Japan's alliance with Germany in 1940 drew them into Germany's confrontation with Britain and eventually America. Japan's decision to prioritize navy over army, or vice versa at different moments, created inter-service rivalry that hampered coordination. The industrial dimension, however, was fundamental. Japan's entire industrial base couldn't match American automotive production alone. In 1941, before war mobilization, American factories built over 3 million automobiles. Japan's steel production that year was 6.7 million tons. America's steel production was 75 million tons. The ratio was 11 to 1. Those numbers determined the war's outcome before the first shot was fired. Japan entered a war of attrition against an opponent with 11 times their steel production. The strategy required either quick victory before American industry mobilized, or a negotiated peace before American material superiority became overwhelming. Neither happened. By May 1945, when Genda flew the Corsair, the war had been decided by industrial capacity. The atomic bombs in August simply accelerated the inevitable conclusion. Japan couldn't have continued fighting even without nuclear weapons. Conventional bombing had destroyed Japanese cities. Conventional submarines had strangled Japanese shipping, and conventional forces were preparing to invade. The atomic bombs provided Emperor Hirohito with justification to surrender, but surrender was inevitable regardless. The Corsair's role in this vast tragedy was small but illustrative. 12,571 Corsairs helped establish American air superiority over the Pacific. They shot down Japanese aircraft, bombed Japanese positions, supported American advances across the island chains. Each Corsair represented American industrial capacity applied to military purpose, and American industrial capacity was greater than anything Japan could counter. Genda understood this during his 20-minute flight. He felt it in the powerful engine, saw it in the robust construction, recognized it in the systematic design. The Corsair wasn't a miracle of engineering. It was the product of a nation with virtually unlimited resources focused on winning a war. Japan had limited resources, increasing desperation, and no path to victory. Flying the Corsair made that truth undeniable. Today, historians studying the Pacific War examine the industrial dimension carefully. They analyze production statistics, resource allocations, supply chain logistics. They recognize that battles were important tactically, but industrial capacity determined strategic outcomes. Midway mattered because America could replace lost carriers quickly. Japan couldn't. Guadalcanal mattered because America could sustain forces indefinitely. Japan couldn't. The Marianas mattered because America could base B-29s there to bomb Japanese factories. Japan couldn't bomb American factories. The captured Corsair served as microcosm of this larger reality. Japanese technicians examined it thoroughly. They documented every detail. They understood American engineering philosophy. They recognized American manufacturing efficiency. They saw the future clearly. and they realized Japan wasn't part of it. Genda's flight report, preserved in Japanese archives and later translated by American historians, contains one final observation, often overlooked. He wrote, "The Americans have solved the problem of industrial warfare. They have created a system that transforms raw materials into finished weapons with minimal human intervention. Their factories are machines that produce machines. This is the future of warfare. The nation with superior industrial systems will defeat the nation with superior warriors. We trained warriors. They built systems. Systems won." That observation, written by a fighter pilot who helped plan Pearl Harbor and ended his career rebuilding Japan's Air Force, captured the Pacific War's essential truth. Individual courage mattered, tactical skill mattered, strategic planning mattered, but industrial capacity mattered more. America had it. Japan didn't. That difference, more than any battle or campaign, determined the war's outcome. The Corsair was just one aircraft among tens of thousands, but it represented the principle perfectly. Fast, powerful, reliable, and produced in overwhelming numbers. American industry could build 12,571 of them, while Japan's entire production system collapsed. That was the war's story, not Pearl Harbor or Midway or Iwo Jima. Those were dramatic moments in a contest already decided by industrial mathematics. Genda lived long enough to see this understanding become historical consensus. He witnessed Japan's post-war economic transformation, watched Japanese factories adopt American production methods, saw Japanese exports dominate world markets. The irony pleased him. Japan had learned the lesson, just decades too late to matter militarily. In his final years, Genda occasionally spoke to students studying military history. He described the war honestly, without romanticization or bitterness. When asked what single moment crystallized his understanding of Japan's strategic situation, he always mentioned the same event. May 20th, 1945. 20 minutes in a captured Corsair. The day he understood completely. "I flew the best aircraft Japanese engineers could capture and repair," he would tell students. "For 20 minutes, I had access to American technology. I felt American power. And I realized we were fighting a war we'd already lost 3 years earlier. We just didn't know it yet. The Corsair taught me that truth. It was an expensive education." Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.